Another type of energy used to produce electricity is nuclear power. Nuclear power uses the energy released by nuclear fission, the splitting of an atomic nucleus into two smaller fragments, causing the release of a lot of energy. This should not be confused with nuclear fusion, which is the joining of two atomic nuclei into a single, heavier nucleus. Fusion is how energy is produced by the sun and has yet to be reproduced on Earth as a viable alternative to fission. Nuclear fission reactions are initiated and maintained in nuclear power plants by the nuclear reactor. In a nuclear reactor, neutrons attach to uranium-235, turning it into uranium-236, which is unstable and splits into two lighter elements and releases more neutrons, which then attach to more uranium, causing a chain reaction. That chain reaction is controlled in the reactor by control rods that are designed to absorb neutrons. The heat generated by this fission reaction is used to heat water and produce steam that then spins a turbine and generates electricity. Nuclear power does not produce greenhouse gases. However, nuclear power also produces radioactive waste that is extremely harmful to humans and to the environment. The mining of materials needed for nuclear reactors is also fossil fuel dependent, and the development and running of nuclear power plants can be very expensive. Nuclear reactors, if not run properly or damaged by natural disasters, can cause an extremely dangerous human and environmental catastrophe. For example, poor design and human error caused a catastrophic meltdown of the Chernobyl nuclear power plant in what was then the Ukrainian SSR. During a safety test on April 26, 1986, the cooling system in reactor number 4 malfunctioned, caused a massive explosion, releasing radioactive particles and smoke over the nearby city of Pripyat, and spread over much of Europe. More recently, on March 11, 2011, the power systems at the Fukushima Daiichi power plant in Japan were knocked out by a 9.0 magnitude earthquake and subsequent tsunami. This lapse in power caused reactors to overheat and explode, releasing harmful radiation and contaminating local water and food supplies. While these two disasters were horrific, most nuclear power plants work well and under proper regulation and safeguards can run extremely safely. The larger issue facing nuclear power plants is disposal of radioactive waste. Radioactive solids, liquids, and gases give off harmful radiation as they decay. As radioactive material, or isotopes, release radiation, they decay, and the rate that they decay to half of their original amount is called a half-life. For some radioactive isotopes, this can be a few days. However, for many of the waste products produced by nuclear reactors, like plutonium-240 and neptunium-237, their half-life is measured in thousands, 10,000s, or even millions of years. The major issue then of disposing of this harmful material is the issue of extreme long-term storage. Currently, most radioactive waste is stored in specialized casks that are designed to contain the radioactive material and its radiation. However, these are only a temporary solution because the radioactive material inside will long outlast the metal surrounding it. A more permanent solution to dealing with radioactive waste is to bury it deep underground. While this is an ongoing issue, a fully fleshed out solution and plan has not been implemented and continues to be one of the most important issues related to nuclear powered electricity production.